Okay, here is our first conservation of momentum problem. We have a cannonball being shot and a circus performer catching it. Initially, the momentum is all in the cannonball, and then afterwards, it's the combined mass of the performer and of the ball. So this is a perfectly inelastic collision, and in a perfectly inelastic collision, momentum is conserved. So conservation of momentum. We have that the final momentum is equal to the initial momentum. So let's look at the initial. Well, what do we know? So we have some knowns. We have the mass of the ball, and that's 10 kilograms. And we have the mass of the performer, which is 65 kilograms. And we know the initial velocity of the ball. Now, this is a one-dimensional problem, so we can just talk about speeds, that whether if they're positive, they're in the positive x direction. If they're negative, they're in the negative x direction. So the initial velocity is 8 meters per second. So what's our initial momentum? Our initial momentum is just the mass of the ball times the initial speed. So the mass of the ball was 10 kilograms, speed was 8 meters per second, so our initial momentum is 80 kilograms times meters per second. Alright, what's our final momentum? Our final momentum is the combined object of the mass and the performer. So that's the mass of the ball plus the mass of the performer, and we multiply it by our final velocity of the combined object, which is the mass of the ball and the performer together. So we can substitute in some numbers. We can substitute in the mass of the ball and the mass of the performer, and that gives us a total of 75 kilograms. And we don't know what the final velocity, the final speed is. But we do know momentum is conserved, so the initial momentum is equal to the final. So plugging in some numbers, writing the equation out, we have 80 kilograms times meters per second is equal to 75 kilograms times our final speed. Solving for our final speed, we get 80. If you note, the kilograms cancel, and we're going to be left with units of meters per second. We divide by 75, and we end up with 1.07, I believe, meters per second. Note that it's positive, so the combined object of the mass of the ball and of the performer is in the same direction as the initial momentum. Okay. Well, sorry, the velocity is in the same direction as the initial velocity.